Alright, cosmic voyagers, settle in. Let the mundane anxieties of your day, those little terrestrial gremlins chewing on your peace of mind, just dissolve. Picture them, if you will, like tiny, insistent mosquitoes trying to get through the triple-pane window of a spaceship. Annoying, yes, but ultimately out there. And tonight, we are going way out there. Further than your mounting credit card debt, further than that awkward thing you said at work 3 years ago that still haunts your midnight reveries. We're off to shake hands, metaphorically speaking, of course. Actual handshakes are strongly discouraged, with the solar system's most distant and arguably most aloof bouncer. Welcome, or perhaps brace yourselves for Neptune's chilly welcome mat. Imagine just for a moment that our solar system is a rather exclusive, sprawling nightclub. Mercury is that sweaty, frantic dancer too close to the main speakers. Venus is the mysterious one in the corner, veiled in a toxic, unbreathable atmosphere, beautiful but deadly. Earth is the crowded VIP section, convinced it's the only place the party's really happening. Mars is the slightly desperate, once promising hopeful still trying to get noticed by the DJ. Jupiter is the booming, overly gregarious giant taking up half the dance floor, while Saturn, with its elegant rings, is clearly just here to look fabulous and judge everyone. Uranus is the oddball, spinning on its side, probably into some experimental performance art. And then, way out at the very edge of the velvet rope, stands Neptune. Imposing, deep blue, and radiating an aura that says, yes, you can look, but don't even think about touching. Tonight, we're not just looking. We're going to drift by, close enough to feel the sub-zero breath of this ice giant, to witness the majestic indifference of its storms. The velvet rope here you see isn't some plush, inviting cord. Oh no. It's woven from winds that scream faster than the speed of sound, laced with crystals of frozen methane. Sounds refreshing, doesn't it? Like a spa treatment designed by a sadist with a peculiar fondness for cryogenic torture. But fear not. Here, in this safe cocoon of your mind, wrapped in the soft blanket of curiosity, we are merely observers, ghostly passengers on a current of thought. So take a slow, deep breath. Feel your body becoming heavier, sinking comfortably into whatever surface supports you. And as you exhale, let go of the day's friction, the small abrasions of earthly existence. We're trading them for a much grander, more profound kind of abrasion, the kind that only a planet 3 billion miles away can offer. Yes, 3 billion miles. Roughly 4.5 billion kilometers if you prefer your cosmic distances in metric. A number so large it almost feels rude to contemplate. Imagine writing that many zeros on a check. Your bank manager would have a seizure, and rightly so. It's the kind of distance that makes your longest commute feel like a quick skip to the corner shop for a forgotten pint of milk. As we begin this mental voyage, picture the familiar glow of the sun shrinking behind us. It becomes a brilliant, distant star, still the king, but its immediate, life-giving warmth is now a memory, a postcard from a warmer, more crowded neighborhood. The space around us deepens, becomes more profoundly dark, punctuated by the pinpricks of other suns, other impossibilities. There's a silence out here that's more than just the absence of sound. It's a silence that has weight, a silence that speaks of eons of immense, cold, uncaring emptiness. Comforting, isn't it? In a my problems are cosmically insignificant kind of way. We pass the orbits of the inner rocky worlds, then the colossal gas giants. Even Saturn, with its breathtaking rings, recedes into the star-dusted tapestry behind us. We're venturing into the outer suburbs of our solar system, the wild frontier where the sun's authority wanes, and the true, stark nature of interplanetary space asserts itself. It's colder here. The light is dimmer, more ethereal. And the sense of isolation, even in our shared imagining, can feel palpable. Like being the last guest at a party that ended eons ago, and the host has long since turned into a frozen statue. And there, slowly emerging from the inky black, is a smudge of blue. At first, it's indistinct, a mere hint of color in the void. But as we drift closer, ever so gently, that smudge resolves itself into a sphere. A deep, mesmerizing, almost impossible blue. Not the friendly sky blue of Earth, nor the pale, ethereal blue of Uranus. This is a profound, oceanic, sapphire blue, the kind of blue you might see in the deepest trench of an imaginary ocean, or in the heart of a flawless, ancient gemstone. This is Neptune. It doesn't exactly roll out a red carpet. More like an ice blue one, probably slick with frozen ammonia and smelling faintly of, well, things you'd rather not contemplate smelling right before bedtime. This is the guardian of the solar system's edge, the eighth and most distant officially recognized planet since Pluto got demoted, a controversial topic we won't get into tonight, lest we trigger a cosmic debate society in your subconscious. Neptune, named for the Roman god of the sea, which is rather fitting for its color, though perhaps less so for its complete and utter lack of any actual Earth-like seas. Any water here is frozen harder than a lone shark's heart. This is a world of extremes, a place where earthly intuition goes to die a quick, frozen death. It's an ice giant, a category of planet that sounds rather majestic, conjuring images of frosty titans. And it is. But ice in planetary science doesn't just mean frozen water. It means a delightful cocktail of water, ammonia, and methane, compressed under such staggering pressures that they behave in ways that would make a terrestrial physicist weep with bewildered joy, or possibly just weep. So, as we hover here at the precipice of Neptune's domain, let that deep blue fill your mind's eye. It's a cold beauty, a remote majesty. It's the kind of beauty that doesn't need your approval, doesn't seek your admiration. It simply is. A silent, spinning testament to the universe's ability to create wonders in the most inhospitable of places. This is Neptune's welcome mat, vast, frigid, and utterly indifferent. And yet, strangely, inviting us to peer closer, to whisper our questions into its supersonic, icy winds. Let the thought of that immense distance, that profound cold, that stark beauty, begin to draw you further away from your worries and deeper into the cosmic quiet. The bouncer is staring. Let's not keep him waiting. And so we drift. There's no sudden lurch, no dramatic engine burn. Our journey through the void is a seamless glide, as if the universe itself is gently exhaling us towards this distant, azure sentinel. Feel that sense of effortless motion, a slow, unhurried passage across an ocean of almost incomprehensible scale. The sun, once a familiar disk, is now just the brightest star in a sky crowded with distant suns, its warmth a faded memory, its gravitational leash feeling stretched almost to its limit. We are truly out on the fringes now, in the far, cold reaches of the kingdom. Imagine holding a tiny pebble in your outstretched hand, and then imagine that pebble is Earth. Now, picture yourself standing on the shore of an immense, dark ocean, and flicking that pebble into the waves. The distance it travels before it disappears beneath the surface is, relatively speaking, far less than the journey we've just made from our home world to this 8th planetary outpost. It's a humbling thought, isn't it? All our drama, our triumphs, our tiny, squabbling empires, contained on that receding speck. Out here, perspective has a way of recalibrating itself with a rather blunt cosmic efficiency. You start to feel rather small, like a forgotten to-do list item in the universe's grand, sprawling, and possibly quite disorganized filing cabinet. Perhaps filed under miscellaneous biological curiosities, carbon-based, surprisingly noisy. This is the billion-mile stare. Or more accurately, the 3 billion-mile stare back towards the heart of the solar system. From Neptune's orbital perch, the inner planets are practically invisible without significant telescopic aid. Lost in the glare of that now-distant Sunday, imagine trying to spot your house keys from several towns away, using only your naked eye, during a blizzard. It's that kind of challenge. This immense distance breeds a sense of profound isolation. If you were to shout, and if sound could travel in the vacuum of space, which, thankfully for the universe's eardrums, it cannot, your voice would dissipate into absolute nothingness long before it reached even the faintest echo of another celestial body of any significant size, save for Neptune's own retinue of moons. It's a silence here that's more than just an absence of vibrating air molecules. It's a primal silence, the silence of deep space, punctuated only by the faint, almost imperceptible hiss of cosmic radiation, the distant whisper of the solar wind as it finally peters out, and the occasional ghostly crackle of charged particles interacting with Neptune's powerful magnetic field. If you could truly listen, unshielded, it might sound like the universe slowly grinding its ancient gears, or perhaps just sighing at the sheer effort of existing. This isn't the comforting quiet of a library, or the peaceful hush of a forest at dawn. This is the silence of the void, vast, empty, and utterly, terrifyingly indifferent to your well-being. Makes you appreciate that dripping tap back home, doesn't it? Or the neighbor's dog that barks at 3 a.m. At least they're signs of something. As we get closer to Neptune, its blue disk swells, no longer a mere smudge but a palpable, gigantic sphere. It still seems impossibly far, yet its presence is becoming dominant in our mental viewfinder. The stars around it seem to dim slightly, overwhelmed by the reflected sunlight, however faint, that paints Neptune in its characteristic hue. You might feel a slight, imagined chill. Even though we are in the vacuum of space and temperature works differently here, the sheer visual impact of this ice giant, a world whose upper atmosphere chills down to a brisk -218 degrees Celsius, or -360 degrees Fahrenheit, is enough to make you want to pull your cosmic blanket a little tighter. That's cold enough to turn air into a liquid. Your breath, were you foolish enough to exhale it without a suit, would instantly become a cloud of tiny ice crystals, a miniature personal blizzard heralding your very swift demise. Cheerful thought that. Think about the journey of light itself. Sunlight, which takes a mere 8 minutes to reach Earth, embarks on a lonely 4-hour trek to illuminate Neptune's cloud tops. 4 hours. Imagine switching on a lamp, and the light only arriving in the next room 4 hours later. You'd probably call an electrician or possibly an exorcist. This delay, this lag in cosmic communication, underscores the sheer scale we're dealing with. If Neptune were to suddenly, say, explode, highly unlikely, but let's indulge a dramatic, if inaccurate, fancy, we on Earth wouldn't know about it for over 4 hours. The universe delivers its bad news on a significant time delay, like a postcard announcing a disaster that has already happened, leaving you to wonder if you should still send that fruit basket. The gravitational pull of Neptune, though immense by human standards, feels subtle from our current vantage point. We are not plummeting towards it, but rather gliding into a graceful, distant orbit. It's a slow dance, choreographed by the laws of physics, a silent ballet performed by celestial bodies across unimaginable distances. There's a strange serenity in this. Out here, away from the hustle and bustle of the inner solar system, things move with a certain ponderous grace. Or perhaps it's just that time itself feels different, stretched thin and cold, like ancient taffy. Human lifespans are but a fleeting instant against the backdrop of Neptune's leisurely 165 Earth-year orbit around the Sun. Imagine celebrating your birthday only once every 165 years. The cake would have to be enormous, and probably very, very stale. This vastness, this cold, this silence, this billion-mile stare, it's not designed to be comforting in the traditional fluffy bunny sense. It's the comfort of perspective. The comfort of realizing that your daily anxieties, the things that keep you up at 2 a.m. staring at the ceiling, are, in the grand scheme of Neptune and its silent, swirling storms, less than a speck of cosmic dust. They are a brief flicker in the face of eternal, icy majesty. And there's a strange kind of peace in that, isn't there? A peace born not from blissful ignorance, but from a stark, clear-eyed acknowledgement of our own delightful, absurd insignificance. The universe is vast and doesn't know your name. And that, my friends, can be remarkably liberating. So let that feeling of smallness, of being a tiny, warm consciousness adrift in a cold, dark ocean, not be a source of fear but a gentle release. You are a fleck of awareness in an infinite expanse. And for tonight, that is more than enough. It's everything. And now, let that deep, mesmerizing blue of Neptune truly fill your awareness. As we draw nearer, not to land, oh heavens no, landing is a concept that Neptune treats with icy disdain, but to drift as a silent observer in its upper atmospheric reaches, the color intensifies. It's a blue that seems to swallow light, a blue that hints at unfathomable depths. This is Neptune's signature, its calling card, the azure jewel shimmering at the frozen heart of the outer solar system. Imagine dipping a paintbrush into the twilight sky just as the last rays of sun surrender to the night, then mixing that with the deepest sapphire you can conceive, and perhaps a dash of royal purple for mystery. Even then, you might not quite capture the specific vibrant hue of Neptune. It's a color that speaks of cold, of immense pressure, of alien chemistry. It's not the welcoming blue of a tropical ocean, inviting you for a swim. This is a blue that warns, that mesmerizes, that holds secrets within its swirling, cloudy depths. It's the kind of blue you'd expect to find in the gaze of an ancient, very powerful, and slightly grumpy deity of the sea, just before he unleashes a rather spectacular tempest. This isn't just a surface color, a thin veneer. The blue is atmospheric, a deep, pervasive tint that goes down and down and down far further than our eyes or indeed our current spacecraft can penetrate. It's like looking into an infinitely deep well, dyed with the essence of midnight. There's a purity to it, an intensity that's almost hypnotic. You could lose yourself in that blue, tracing the subtle variations, the lighter streaks of high-altitude clouds against the darker, more uniform background. It's a living color, constantly shifting, stirred by winds we can only begin to imagine. But let's not get too romantic about it. This beauty, like so much cosmic beauty, is born from conditions that would be instantly, spectacularly lethal to any unprotected human. The azure jewel aspect is undeniable. The frozen heart part? Equally true and significantly less poetic if you happen to value things like, say, not having your internal organs crystallize. The temperature at the 1 bar pressure level, a common reference point in planetary atmospheres, is a brisk minus 201 degrees Celsius, that's minus 330 Fahrenheit. And it only gets colder as you go higher into the wispy cloud tops. This is a cold that doesn't just numb, it shatters. It's a cold that makes Antarctica in winter look like a balmy beach vacation. Your sturdiest thermal underwear would simply give up and disintegrate in protest. So, as we admire this stunning, frigid gem, let's appreciate the paradox. Such profound beauty, forged in such an extreme environment. It's a recurring theme in the universe, isn't it? The most breathtaking nebulae are cauldrons of radiation and stellar birth pangs. The most elegant galaxies are driven by supermassive black holes that could swallow our entire solar system for a light snack. Neptune's beauty is no different. It's a harsh, indifferent beauty, a beauty that exists for itself, utterly unconcerned with whether we find it appealing or indeed survivable. And that, in its own stark way, is part of its allure. It doesn't need us. It's magnificent all on its own, thank you very much. Think of the light interacting with this atmosphere. Sunlight, already weakened by its 4-hour journey, arrives at Neptune. Some of it is reflected away, but some penetrates the upper layers. And it's in this interaction that the magic, or rather, the physics, happens. The specific gases in Neptune's atmosphere are very good at absorbing certain colors of light and scattering others. It's like a selective filter, a cosmic artist carefully choosing its palette. We'll get into the specifics of which gas is the primary culprit for this dramatic coloration shortly, but for now, just absorb the visual impact. This deep blue isn't uniform either. As we get closer, we begin to see structure. Wispy white clouds, looking like brushstrokes of cirrus against the darker canvas, streak across the planet. These are not water ice clouds like the ones we see on Earth. Oh no, Neptune has more exotic taste. These are likely methane ice crystals, frozen droplets of natural gas, essentially. Imagine a sky where the clouds are made of the same stuff that fuels your stove, only very, very cold. It gives a whole new meaning to freezer burn. These clouds, often elongated and streaky, are evidence of the colossal winds that tear through Neptune's atmosphere, winds we'll brace ourselves for, mentally of course, a little later. They trace the high-speed jet streams, painting ephemeral patterns on a canvas billions of miles wide. And then there are the spots, or sometimes the lack of spots. Neptune is famous for its great dark spots, massive storm systems that are, in some ways, analogous to Jupiter's great red spot. But Neptune's spots are far more capricious, more ghostly. They appear, they swirl, they rage with unimaginable ferocity, and then, they fade away, sometimes within a few years. Like giant, moody bruises on the face of the planet, appearing and disappearing as if Neptune itself is sighing them into and out of existence. We might catch a glimpse of one, or perhaps the ghostly remnants of one, a subtle darkening in that otherwise vibrant blue. These are windows, perhaps, into even deeper, more turbulent layers of the atmosphere, places where the pressure and temperature climb to truly mind-boggling levels. This whole spectacle, this deep blue sphere adorned with white streaks and shadowy storms, is spinning. Neptune completes a rotation in about 16 Earth hours. So, if you could stand on a non-existent, solid surface, your day would be significantly shorter. More time for, well, for freezing, presumably. But it means the view is constantly changing, the patterns shifting, the subtle interplay of light and shadow evolving as the planet pirouettes in the faint sunlight. So let this image imprint itself on your mind, this vast azure jewel, suspended in the blackness of space, its heart frozen, its face a mask of cold, dynamic beauty. It's a reminder that the universe doesn't operate on human scales of comfort or hospitality. It creates wonders according to its own rules, its own immense and often terrifying power. And our privilege is simply to observe, to marvel, and perhaps in that marveling, to find a strange kind of peace, a release from our small terrestrial concerns. The frozen heart of Neptune beats to a rhythm far older and slower than our own fleeting anxieties. Let its cold, steady pulse soothe you. Now let's pull back the curtain just a little on this mesmerizing azure spectacle. Why blue? Why this particular, profound, almost unsettling shade of blue that seems to define Neptune's very essence? Is it, perhaps, because Neptune is secretly a brooding artist, expressing its existential angst through carefully chosen hues? Or maybe it's just feeling a bit down being so far from the sun's warmth? While these are charmingly anthropomorphic notions, the truth, as is often the case in the cosmos, is a bit more gaseous. And a lot less romantic, though no less fascinating. The methane blues. Less about soulful poetry, more about atmospheric flatulence on a planetary scale. The primary culprit, the atmospheric vandal responsible for spray painting Neptune this incredible color, is methane. Yes, good old methane, CH4. The same natural gas that, back on Earth, we associate with cows, swamps, and occasionally, that pilot light you forgot to check on your boiler. It's not exactly the most glamorous of substances, is it? You don't typically write sonnets to methane. You don't name luxury perfumes Ode to Methane. And yet, out here in the frigid upper atmosphere of an ice giant, this humble hydrocarbon performs a rather spectacular optical trick. Here's how it works, in a nutshell, that won't require a degree in atmospheric physics, which is good, because those are notoriously difficult to obtain while trying to fall asleep. Sunlight, as we know, is made up of all the colors of the rainbow, a spectrum of light waves of different lengths. When this sunlight penetrates Neptune's upper atmosphere, it encounters methane gas. Now, methane molecules have a particular fondness for absorbing red and infrared light. They gobble it up like a cosmic Pac-Man munching on ruddy-colored pellets. What they don't absorb so well are the blue and green wavelengths. These shorter wavelengths of light are instead scattered by the methane molecules, bounced around and reflected back out into space. This process is called Rayleigh scattering, the very same phenomenon, by the way, that makes Earth's sky blue. On Earth, it's primarily nitrogen and oxygen molecules doing the scattering. On Neptune, methane takes center stage in this light scattering drama. Because the red light is largely absorbed, and the blue light is largely scattered back towards our imaginary viewpoint, what we see is that dominant, striking blue. The more methane there is, and the deeper the atmosphere the light can penetrate before being absorbed or reflected, the deeper and richer that blue can become. Uranus, Neptune's slightly smaller, paler blue sibling, also owes its color to methane. But Uranus is a lighter, cyan shade. The current thinking is that Neptune's more vivid, intense blue suggests that its atmosphere might have a different concentration or distribution of methane, or perhaps other as yet unidentified chromophores, color-causing compounds, lurking in its cloudy depths. Or maybe Neptune just has a more efficient system for trapping those red photons. It's like it's really committed to the blue aesthetic. Uranus is dabbling. Neptune is a full-blown blue aficionado. So, when you gaze upon that breathtaking, sapphire sphere, remember that you're essentially looking at a giant, very cold ball of gas that's particularly good at filtering sunlight. It's a bit like looking at the world through a very sophisticated, planet-sized blue lens. It kind of demystifies it a bit, doesn't it? That profound, brooding beauty, the color that seems to speak of ancient maritime gods and fathomless oceans. Well, it's mostly down to the way light interacts with the gaseous equivalent of a colossal cow burp. Terribly sorry if that shatters any poetic illusions. The universe, in its infinite wisdom, often pairs the sublime with the slightly ridiculous. Or, in this case, the gaseous. It's not just methane, of course. The atmosphere of Neptune is primarily hydrogen, about 80%, and helium, about 19%, the two lightest and most abundant elements in the universe. These are the basic building blocks of gas giants and ice giants. Methane itself is present in smaller quantities, perhaps a few percent in the upper atmosphere. But it's a potent absorber of red light, so it doesn't take much to have a dramatic, colorful impact. Think of it like a tiny bit of very strong dye in a huge vat of water. There might also be other trace gases, hazes, and aerosols contributing to the exact shade and texture of Neptune's appearance. Scientists speculate about clouds of hydrogen sulfide, yes, the rotten egg gas, how delightful, ammonia ice, water ice, and ammonium hydrosulfide, all layered at different depths, creating a complex atmospheric chemistry that we are only just beginning to unravel. Imagine a tiered cake, but instead of delicious sponge and cream, you have layers of noxious, freezing gases. Appetizing, no? It's this complex layering and mixing, driven by Neptune's internal heat and rapid rotation, that likely contributes to the dynamic features we see, like those wispy white methane ice cirrus clouds we mentioned earlier, which float high above the main blue cloud deck. So, the next time you feel a bit blue, remember Neptune. Its blues aren't born from sadness, but from a specific and rather mundane chemical interaction on a colossal scale. It's a blue of physics, a blue of atmospheric composition. And yet, it's still beautiful, isn't it? Knowing the science behind it doesn't have to diminish the wonder. In fact, it can enhance it. It connects this distant alien world to the same fundamental laws of light and matter that govern our own blue sky. It's a shared heritage of physics, a reminder that the universe, for all its bewildering complexity and occasional bad breath, operates on consistent principles. So let the methane blues wash over you. Not the sad kind, but the scientific kind. The kind that paints a world 3 billion miles away in hues of sapphire and azure, all thanks to a bit of gas that's more famous for its less than glamorous earthly associations. It's a humbling and faintly amusing truth. The cosmos has a strange sense of humor, dressing up one of its most distant giants in the cast-off color palette of a swamp. Sleep well, knowing that even the most majestic beauty can have remarkably humble and slightly gassy origins. Now, as we continue our gentle imaginary drift closer to Neptune's vibrant blue facade, let's tune our senses, or rather, our imagination of our senses, to another of its defining and frankly terrifying characteristics. We've admired its color, born of methane's selective light absorption. But Neptune isn't just a pretty, static blue bauble hanging in space. Oh no. This planet is a symphony of violence, a realm of unimaginable atmospheric fury. We're talking about winds. Winds that make earthly hurricanes look like a gentle summer breeze ruffling your hair. Winds that are, to put it mildly, supersonic. Welcome to Neptune, where the weather forecast is always extreme wind warning, and your only hope of survival is to be a disembodied consciousness on a relaxing bedtime journey. Picture this. On Earth, the fastest winds ever reliably recorded in a hurricane or tornado might gust up to, say, 300 miles per hour, or around 480 kilometers per hour. Terrifying, destructive, capable of leveling towns. Now take that speed and multiply it. Multiply it by 4 or even 5. On Neptune, winds have been clocked raging at speeds of over 1,200 miles per hour, or nearly 2,000 kilometers per hour. That is faster than the speed of sound in Neptune's atmosphere. Let that sink in for a moment. These are not just gales. These are sustained, planet-circling jet streams of almost incomprehensible velocity. Imagine trying to stand in a wind like that. You wouldn't. You'd be atomized. You'd be flayed, scoured, and dispersed across the upper atmosphere as a thin, regrettable smear of organic particles before you even had time to register your profound mistake. It's the kind of wind that doesn't just knock your hat off. It knocks your atoms off. Thankfully, in our current, wonderfully invulnerable state of imaginative travel, we can observe this meteorological mayhem without any personal risk. We are ghosts in this machine, untouchable, unflayable. Why so fast? This is one of Neptune's enduring mysteries. On Jupiter and Saturn, massive, fast winds are largely driven by the internal heat escaping from the planet's cores, combined with their rapid rotation. But Neptune is much further from the Sun. It receives only about 1/900th of the solar energy that Earth does. Its internal heat source, while surprisingly potent for its size and distance, we'll touch on that later, is still modest compared to Jupiter's internal furnace. So what gives these winds their incredible record-breaking poke? Scientists are still scratching their heads, or perhaps, more accurately, running complex computer simulations that probably look like a Technicolor explosion. One idea is that because Neptune's atmosphere is so incredibly cold, there's less friction than in warmer, denser atmospheres like Jupiter's. It's like ice skating. On a smooth, icy surface, you can glide much further and faster with less effort than if you were trying to skate on, say, treacle. The frigid, slippery nature of Neptune's upper atmospheric gases might allow these winds to whip around with far less resistance, building up to these astonishing speeds. It's a smooth flow hypothesis, which sounds deceptively gentle for something capable of tearing a spaceship apart. And what would these winds sound like? Well, here's a lovely, if unsettling, cosmic truth for you. In the near vacuum of space where we are currently notionally hovering, and even in the tenuous upper layers of Neptune's atmosphere that we are observing, sound doesn't travel in the way we experience it on Earth. Sound needs a medium to propagate, a medium dense enough for pressure waves to move through. While Neptune certainly has an atmosphere, its outermost layers are incredibly thin. So, even if these winds were screaming past at Mach 2 or Mach 3, creating unimaginable turbulence and pressure fluctuations within those gas layers, you, as an external observer in a hypothetical and very sturdy spacecraft, would hear nothing. Silence. An absolute, profound, eerie silence accompanying a spectacle of unimaginable violence. Your loudest, most terrified shriek, should you be foolish enough to attempt one out here, would be swallowed by the void before it even left your lips. A very, very final silence. Makes you appreciate that annoying car alarm down the street, doesn't it? At least it's proof of an atmosphere, of a world where sound can still carry a warning, or just an irritation. Out here, the universe plays its most terrifying symphonies on mute. But let's imagine, just for the sake of our multisensory journey, what it might be like if we could somehow translate those pressure waves into audible sound. It wouldn't be a gentle whistle. It would likely be a deafening, chaotic roar, a continuous, overwhelming barrage of low-frequency rumbles and high-pitched shrieks, the sound of an entire planet's worth of air being torn apart and flung around at supersonic speeds. Perhaps punctuated by the crash and boom of titanic lightning storms, which are also thought to occur deep within Neptune's turbulent clouds, far below the visible methane ice cirrus. It would be the sound of raw, untamed power, a sound that would vibrate through your very bones, assuming your bones hadn't already been turned into a fine powder. It's this constant, ferocious churn that shapes Neptune's appearance. Those streaky white clouds? They are dragged and distorted by these winds, tracing the paths of colossal jet streams. The great dark spots, those ephemeral storms? They are vast vortices, atmospheric hurricanes larger than Earth, spun into existence and then torn apart by these relentless currents. It's a planet in a perpetual state of atmospheric war with itself. And yet, from our safe, sleepy distance, there's a strange, detached beauty to it. The silent, furious ballet of clouds and storms, painted in shades of deepest blue and starkest white. It's like watching a time-lapse of a terrestrial hurricane, but magnified 1,000-fold in scale and ferocity, and thankfully with the sound turned off. It's a reminder of the sheer energy contained within these distant worlds, energy that dwarfs anything humanity can currently conceive of unleashing. So, as you lie there, feeling the gentle rhythm of your own breath, a breath that moves at a wonderfully slow, subsonic pace, contemplate those silent, screaming winds of Neptune. Let the thought of that incredible, untamed power, so far removed from your own quiet space, paradoxically deepen your sense of peace. You are here safe and still. Neptune is out there, tearing itself apart in a beautiful, silent frenzy. And for tonight, that distance is a profound comfort. The nightmares are Neptune's, the peaceful dreams, hopefully, are yours. Having mentally braced ourselves against winds that could peel the skin from our bones, were we made of such inconveniently solid stuff on this journey, let's turn our gaze to one of Neptune's most enigmatic and famous features, its great dark spots. Or rather, its intermittent, somewhat unreliable, and frankly quite shy great dark spots. This isn't like Jupiter's great red spot, that belligerent, crimson eye that has been staring back at us for centuries, a veritable Methuselah of atmospheric storms. Oh no, Neptune's spots are more like cosmic phantoms, playing a rather frustrating game of celestial peekaboo. We are chasing phantoms, engaging in a sleepy, slow-motion chase across the deep blue face of this ice giant. When Voyager 2, humanity's only robotic emissary to brave these frigid outer realms, zipped past Neptune in 1989, it sent back astonishing images. And there, stark against the sapphire backdrop, was the Great Dark Spot, a colossal, bruise-like anticyclonic storm system, roughly the size of Earth. It was accompanied by smaller, bright white scooter clouds of methane ice that zipped around its edges even faster than the main storm body, like frantic little pilot fish clinging to a vast, dark whale. It was magnificent, mysterious, and seemed like a permanent fixture, Neptune's answer to Jupiter's iconic blemish. For a few years, astronomers watched it through the Hubble Space Telescope. It swirled. It drifted. It pulsed with an inner, unseen energy. And then, in 1994, when Hubble turned its gaze back to Neptune, expecting to see its old, dark friend, it was gone. Vanished. Poof. As if Neptune had simply sighed and erased it, like a chalk drawing on a cosmic blackboard. Imagine planning a tourist trip to see a famous landmark, only to arrive and find it has packed up and left without so much as a forwarding address. That's the kind of frustrating enigma Neptune presents with its spots. This "now you see me, now you don't" act is characteristic of Neptune's dark spots. Since that first one disappeared, others have appeared in different locations with different shapes and sizes, only to fade away again after a few years or sometimes even just a few months. There was Great Dark Spot 2, imaginative naming, astronomers truly, and various other, smaller dark smudges that have come and gone. It's like Neptune is constantly trying on new stormy accessories, then quickly getting bored and discarding them. Does this Earth-sized vortex bring out the blue in my atmosphere? Then, nah, not feeling it anymore. So what are these fleeting, shadowy behemoths? They are believed to be anticyclonic storms, similar in nature to Jupiter's Great Red Spot, meaning they are high-pressure systems that rotate in the opposite direction to the planet's rotation in their respective hemispheres. They are essentially colossal atmospheric vortices, swirling masses of gas that are clearer and less cloudy than their surroundings, allowing us to see deeper into Neptune's atmosphere. The darkness is thought to be a result of these clearings, revealing lower, darker cloud layers, or perhaps a region where certain chemical reactions create darker colored compounds. Think of them as holes, or rather windows, punched temporarily into the upper cloud deck by powerful upwelling and downwelling currents. These windows reveal a glimpse of what lies beneath, a tantalizing peek into the planet's deeper, more mysterious layers. But unlike Jupiter's Great Red Spot, which is incredibly stable and long-lived, Neptune's spots seem to be much more transient, forming and dissipating on timescales of years rather than centuries. Why the difference? Why is Jupiter's spot so stubbornly persistent, while Neptune's are so flighty? The exact reasons are still being debated, filed under things we shout at Neptune through telescopes and hope it answers. It might be related to differences in atmospheric dynamics, the strength of the underlying jet streams, or the way heat is transported from the planet's interior. Perhaps Neptune's atmosphere is just more fickle, more prone to dramatic, short-lived outbursts rather than sustained, brooding tempests. It has a shorter attention span for its superstorms. As we peer at Neptune's face now, in our mind's eye, perhaps we see one. A subtle darkening, an oval smudge against the vibrant blue. Or maybe we see a region where one used to be, a slightly disturbed patch of atmosphere, like the faint imprint left on a cushion after someone has been sitting there. Or perhaps today, Neptune is in a spotless mood, presenting a more uniform, unblemished facade. The chase is often more about the anticipation, the possibility, than the actual sighting. These spots are not just surface features. They are deeply rooted in the planet's atmospheric circulation. They can drift latitudinally, moving north or south, sometimes oscillating back and forth before they finally break apart. They are also often associated with those bright, high-altitude methane ice companion clouds, those scooters we mentioned. These bright clouds form when air flows up and over the dark vortex, causing gases like methane to freeze out at higher, colder altitudes, creating brilliant white plumes that often precede or flank the main dark spot. It's like the storm has its own little entourage of icy heralds. Imagine trying to study something so vast, so powerful, yet so ephemeral from 3 billion miles away. It's a cosmic game of hide and seek played on a planetary scale, with observation windows limited by telescope availability and the sheer, frustrating distance. Each new image, each new data point, adds another piece to the puzzle, but the full picture remains elusive, shrouded in blue haze and supersonic winds. There's a certain poignant beauty to their fleeting nature though, isn't there? These colossal storms, larger than our entire world, are born, live their furious lives, and then die, all within a cosmic blink of an eye. It's a reminder of the dynamic, ever-changing nature of even these seemingly eternal giants. Nothing is static, not even a storm the size of a planet. They are like Neptune's moods, writ large across its face for a brief, spectacular moment, then smoothed away by the relentless winds, leaving only the deep, enigmatic blue. So, as we drift, we watch, we wait. Perhaps a phantom will reveal itself. Perhaps not. The mystery itself is part of the allure, part of the sleepy chase. And in that uncertainty, there's a strange kind of peace. The universe keeps its secrets well. As we continue our spectral tour, floating like ethereal dust motes in the upper atmosphere of Neptune, let your gaze be drawn to those delicate, almost feathery white streaks that lace across the dominant blue. We've touched upon them briefly, but they deserve a moment of their own, these cirrus clouds of ice. They are undeniably pretty, adding streaks of brightness and texture to Neptune's otherwise deep and sometimes brooding countenance. But like so much of Neptune's beauty, there's a catch. A rather significant, lung-crystallizing catch. So marvel at their delicate forms, their ghostly dance in the supersonic winds, but for goodness sake, don't inhale. These are not your friendly, fluffy terrestrial water ice cirrus clouds, those harbingers of fair weather or approaching fronts that you might see on a summer's day on Earth. No, Neptune, as we've established, has a more exotic palette. These high-altitude clouds, the highest visible cloud features on the planet, are primarily composed of methane ice crystals. Methane CH4. Yes, again with the methane. It's the Swiss Army knife of Neptunian atmospheric phenomena. It colors the planet blue, and it forms its highest, prettiest clouds. It's a multi-talented, if somewhat odorous, gas. Imagine looking up into a sky, not of pale blue, but of deepest, richest sapphire. And against that incredible backdrop, you see these brilliant white filaments, so fine they look like they were spun from starlight, or perhaps like an artist took a very fine brush dipped in pure white and dragged it gently across the blue canvas. These are the methane ice clouds. They typically form at altitudes where the temperature drops to around -220 degrees Celsius. That's a chilly -364 degrees Fahrenheit. At these frigid temperatures, Any gaseous methane present in the upwelling atmospheric currents freezes directly into tiny ice particles, forming these visible cloud structures. They often appear as long, linear streaks, sometimes stretching for thousands of kilometers, aligned with Neptune's powerful east-west jet streams. They are like cosmic contrails, tracing the paths of winds we can barely comprehend. Sometimes they form broader, wispier patches, or gather around the edges of those great dark spots, acting as bright collars or companion plumes. They are dynamic, constantly changing, shaped and reshaped by the relentless atmospheric circulation. They are ephemeral brushstrokes on a planetary masterpiece. There's a certain delicate, ethereal beauty to them, isn't there? They look so soft, so pure, so deceptively benign. If you didn't know better, you might imagine them to be as harmless as a wisp of earthly steam. But let's not be fooled by appearances. Pretty, in the cosmos, rarely equates to hospitable. In fact, it's often an inverse relationship. The more stunningly beautiful something is out here, the more likely it is to be instantly fatal. So, let's indulge in a little thought experiment, a common pastime on these cosmic bedtime journeys. Imagine just for a moment that you could somehow be in one of these methane ice clouds without the comforting, life-sustaining bubble of our shared imagination. What would it be like? Well, first, the not inhaling part is crucial. Methane is an asphyxiant. It displaces oxygen. Not that there's any oxygen to speak of in Neptune's atmosphere anyway, but even if there were, a lungful of methane, especially at these temperatures, would be problematic. Your lungs would flash freeze. Instantly. You'd experience a brief, very intense, and rather terminal form of freezer burn from the inside out. Not exactly the relaxing spa experience we're aiming for. And the ice itself? These are not gentle snowflakes. These are crystals of solid natural gas. They would be incredibly cold, sharp, and abrasive if you were to somehow try and touch them. The surrounding atmospheric pressure is also very low at these altitudes. Not quite a vacuum, but certainly not something your terrestrial body is designed to withstand. So, while they look like delicate brushstrokes from afar, up close they represent an environment of extreme cold, low pressure, and unbreathable gas. Beautiful, yes. Inviting? Not in the slightest, unless your idea of a good time involves rapid, multi-system organ failure. It makes that slightly scratchy wool sweater your aunt knitted you feel like the pinnacle of comfort, doesn't it? Yet, these clouds tell us a lot about what's happening in Neptune's atmosphere. Their presence indicates regions of upwelling where warmer, relatively speaking, of course, warmer, on Neptune is still phenomenally cold. Gas from deeper layers is rising, cooling as it expands, and causing the methane to condense and freeze out. Their shapes and movements help scientists map the wind patterns, to understand the flow of energy and material through this complex atmospheric system. They are visible tracers of invisible dynamics, beautiful clues to a planet-sized puzzle. They also contribute to Neptune's overall albedo or reflectivity. These bright white clouds reflect more sunlight back into space than the darker blue regions, subtly influencing the planet's energy balance. It's all part of a complex interplay of absorption, reflection, and emission that determines Neptune's temperature and climate. If climate is even the right word for such a turbulent, alien world. Perhaps perpetual atmospheric tantrum is more accurate. So, as we observe these icy, delicate streamers against the profound blue, let's appreciate them for what they are: beautiful, remote, and utterly inhospitable. They are a testament to the universe's ability to create artistry from the most unlikely and indeed, the most dangerous ingredients. Let their silent, frozen dance be a soothing sight, a reminder that even in the harshest environments, a certain stark beauty can and does flourish. And let the thought of their lung-freezing composition be a gentle nudge towards appreciating the wonderfully breathable, comfortably warm air that currently surrounds you. Not all beauty is meant to be embraced. Some is best admired from a very, very safe distance. And as you drift towards sleep, that distance is infinite. We've marveled at Neptune's deep blue hue, mentally braced against its supersonic winds, and chased its ghostly dark spots. We've even acknowledged the fleeting, historic handshake of Voyager 2. But there's another rather persistent enigma about this distant ice giant, a subtle but significant detail that has planetary scientists furrowing their brows and running their models overtime. It's the mystery of its inner furnace. Neptune, despite being so incredibly far from the sun, and therefore receiving very little solar warmth, is surprisingly warm. Or rather, it radiates significantly more heat than it absorbs from our distant star. Too hot to handle? Well, not in a scorching Venusian sense, but certainly warmer than it should be, making it a faintly unsettling cosmic radiator. Let's put this in perspective. Neptune orbits so far out in the solar system's frigid suburbs that it receives only about 0.1% of the solar intensity that Earth basks in. That's like trying to warm yourself by a bonfire that's several towns away. You'd expect it to be an incredibly cold, inert ball of ice and gas, slowly losing whatever primordial heat it had left from its formation. And it is undoubtedly incredibly cold by any human standard, with those cloud-top temperatures plummeting to below -200 degrees Celsius. However, measurements, particularly those from Voyager 2 and subsequent infrared observations, have shown that Neptune emits about 2.6 times as much energy as it receives from the Sun. That's a significant internal heat source. It's like finding a forgotten thermos flask in the back of your car on a freezing day and discovering it's still inexplicably piping hot. Where is this extra heat coming from? What's stoking Neptune's internal fires, keeping its atmospheric engine running with such vigor, powering those insane winds and dynamic storms? Jupiter and Saturn, the gas giants, also have powerful internal heat sources. For them, it's largely attributed to the Kelvin-Helmholtz mechanism. Essentially, the planets are still slowly contracting under their own immense gravity, and this contraction generates heat. Think of it like slowly squeezing a giant celestial sponge. The friction and compression release energy. This process is also likely happening on Neptune, but calculations suggest it might not be enough to account for the entire discrepancy, for that full 2.6 times factor. Neptune seems to have a little extra something simmering away in its core. Uranus, Neptune's nearest planetary neighbor and fellow ice giant, presents a curious contrast. Uranus is, in fact, colder than expected. It radiates very little internal heat, almost perfectly in balance with the meager sunlight it receives. It's like the sleepy, sluggish sibling next to Neptune's surprisingly energetic, internally fired-up persona. They are both ice giants, similar in size and overall composition, yet they behave so differently in terms of their thermal output. Why is Uranus so chilled out, literally, while Neptune is secretly running a bit of a fever? This discrepancy is one of the great puzzles in comparative planetology. Did something stall Uranus's internal heat engine? Or does Neptune have an additional, ongoing process that Uranus lacks? Several theories have been proposed for Neptune's surprising warmth. One idea involves diamond rain. Deep within Neptune, and Uranus for that matter, the pressures and temperatures are thought to be so extreme that methane molecules can be broken apart. The carbon atoms, squeezed under millions of atmospheres of pressure, could then crystallize into diamonds. Yes, actual diamonds. These newly formed diamonds, being denser than the surrounding material, would then slowly rain down through the planet's deep, fluid mantle, settling towards the core. This diamond rain would release gravitational potential energy as heat, through friction, effectively warming the planet's interior from the bottom up. It's a rather poetic, if highly speculative, way to keep a planet toasty, a constant shower of precious gems generating a planetary fever. Sounds like a rather extravagant form of central heating, doesn't it? Honey, is the planet a bit chilly? Just turn up the diamond precipitation. Another possibility is radioactive decay of elements in Neptune's rocky core, though this is generally thought to contribute only a small fraction of the required heat for gas and ice giants. Perhaps there are ongoing differentiation processes, where heavier elements are still slowly sinking towards the core, releasing energy. Or maybe there are tidal forces at play, though Neptune doesn't have a large, close moon like Jupiter's Io to generate significant tidal heating through flexing. Its largest moon, Triton, is in a retrograde orbit and is actually spiraling inwards, which will eventually lead to its cataclysmic demise, but that's a story for another sleepy chapter. This internal heat is crucial for Neptune's dynamic weather. It's this energy bubbling up from within that helps to drive the atmospheric convection, the rising and sinking of gases, which in turn fuels those record-breaking winds and colossal storm systems like the Great Dark Spots. Without this internal furnace, Neptune's atmosphere might be far more quiescent, more like the comparatively bland, hazy atmosphere of Uranus, though even Uranus has been showing more storm activity in recent years, just to keep us on our toes. So, Neptune's inner fire isn't just a curious thermal anomaly, it's a key ingredient in making the planet the vibrant, tempestuous world we observe. It's a bit unsettling, isn't it? This giant, icy blue world, so far from any obvious source of warmth, yet seething with an internal energy that belies its frigid exterior. It's like a beautifully composed person who you discover has a raging inferno of secret passion hidden deep within. It adds another layer of mystery to Neptune, another reason to gaze at it with a mixture of awe and a slight, respectful apprehension. So, as you settle deeper into your own comfortable warmth, imagine that hidden furnace deep within Neptune. A core, perhaps rocky, perhaps a strange mix of ice and rock under unimaginable pressure, somehow generating this surprising thermal surplus. It's a quiet, constant reminder that even in the coldest, darkest corners of the solar system, there can be unexpected sources of energy, of dynamism. The universe is full of these subtle surprises, these quiet engines running in the dark. And the fact that we don't fully understand them yet only adds to their allure, a gentle hum of mystery that can paradoxically lull us into a state of contemplative rest. Neptune's warm heart, however counterintuitive, is just another fascinating paradox to dream on. We've just touched upon the tantalizing, if somewhat speculative, idea of diamond rain as a potential contributor to Neptune's surprising internal warmth. It's an image that captures the imagination, isn't it? Oceans, or at least deep layers, where carbon, squeezed from methane under unimaginable pressures, crystallizes and slowly, glitteringly sinks towards the core. Diamond showers. It sounds like something out of a particularly opulent fantasy novel. But before you start packing your cosmic mining gear, let's temper that glittering vision with some crushing realities. Because on Neptune, even the most dazzling prospects come with a rather hefty gravitational footnote. The conditions required for this diamond formation are, to put it mildly, extreme. We're talking about depths far below the visible cloud tops, deep into the planet's mantle. Here, the pressures are thought to reach millions of Earth atmospheres, and temperatures soar to thousands of degrees Celsius. It's an environment so alien, so hostile, that it makes the surface of Venus look like a pleasant-day spa. Under these conditions, methane, CH4, molecules which are abundant in ice giants like Neptune and Uranus, can be literally torn apart. The hydrogen atoms separate, and the carbon atoms, under that relentless, crushing pressure, are forced into the tight, crystalline lattice structure of diamond. Laboratory experiments have managed to replicate these conditions, albeit on a microscopic scale, and have indeed observed the formation of tiny nanodiamonds from methane subjected to intense pressure and heat using lasers. So, the physics seems plausible. Extrapolating that to a planetary scale suggests that veritable seas or layers of liquid carbon, with solid diamonds raining or snowing out of it, could exist deep within Neptune. Some models even suggest these diamonds could eventually form a thick, solid layer around the planet's core, a kind of planetary crown jewel hidden deep from view. Imagine it, a slow, perpetual drizzle of diamonds, sinking through a strange, superpressed fluid mantle. It's a process that could have been happening for billions of years, steadily contributing to the planet's internal heat through the release of gravitational potential energy as these denser diamonds sink. It's a beautifully elegant, if mind-boggling mechanism. However, let's bring ourselves, or rather our imaginary, unprotected human forms, into this picture for a moment, just for the sheer masochistic fun of it. Suppose you could somehow be teleported into this diamond-forming region of Neptune. What would be your immediate experience? Well, experience might be too generous a word. Instantaneous obliteration is probably more accurate. Before you could even register the potentially spectacular sight of raining diamonds, assuming you could see in the crushing darkness and infernal heat, the pressure would do its work. Millions of atmospheres. To give you a sense of scale, the deepest part of Earth's oceans, the Challenger Deep, has a pressure of about 1,000 atmospheres. That's enough to crush most submarines like a tin can. Now multiply that by thousands. Your body would be compressed into something resembling a very dense, very small, and very unfortunate puddle of organic matter. The concept of bones would become laughably irrelevant. You would be, to use a technical term, squished. Utterly and comprehensively squished. Into a human pancake, as the saying goes, though even that implies a flatness that might be too generous. More like a human smear. And the temperature? Thousands of degrees Celsius. So, alongside the instantaneous crushing, you'd also be simultaneously vaporized, or at least flash-cooked to a state beyond well done. It's a delightful combination. Extreme pressure and extreme heat, a cosmic recipe for instant disintegration. The diamonds might be beautiful, but the price of admission to their birthplace is rather steep, your entire existence, reduced to its component atoms in a fraction of a second. So, while the idea of diamond showers is wonderfully romantic from a safe 3 billion mile distance, the reality of the environment that creates them is anything but. It's a stark reminder that the universe's wonders are often forged in crucibles of unimaginable violence and extremity. The beauty we perceive is often a mere surface reflection of processes that are utterly inimical to life as we know it. This isn't to be a cosmic buzzkill, deliberately trying to tarnish the glitter of Neptune's potential diamond hoard. It's more about appreciating the sheer raw power of planetary interiors and the vast gulf between our delicate, fragile biology and the conditions that prevail in most of the universe. We are creatures of a very specific, very gentle niche. Our Goldilocks zone is remarkably narrow. Step outside it, especially into the heart of an ice giant, and the universe quickly reminds you that you are very much not in Kansas anymore. Or, indeed, anywhere remotely habitable. Yet there's a strange comfort in this too. Knowing that such incredible alchemical processes are occurring, transforming simple methane into the hardest known natural substance, all hidden deep within that serene blue sphere, adds to Neptune's mystique. It's a planet with hidden depths, hidden treasures, and hidden terrors. It's a world that operates on principles far grander and more powerful than our everyday experiences. So, as you drift towards sleep, feel free to fantasize about those diamond showers. Imagine the slow, glittering rain in the deep, dark, crushing heart of Neptune. But perhaps also spare a thought for the sheer, unadulterated power that creates them. And be grateful for the gentle pressures and comfortable temperatures of your own bed, a haven of softness in a universe that often prefers to be hard, hot, and crushingly indifferent. The diamonds are for Neptune. The peaceful sleep hopefully is for you. They might be pretty, but your mattress is considerably more accommodating. Our journey around Neptune wouldn't be complete without paying a visit to its most prominent and arguably most peculiar attendant, its largest moon, Triton. Triton isn't just another cratered lump of rock quietly minding its own orbital business. Oh no. Triton is a rebel, a captured outsider with a distinctly contrarian attitude and some rather explosive personal habits. Imagine the solar system as a stately, well-ordered ballroom dance, and Triton is the punk rocker who crashed the party, is dancing determinately widdershins, and occasionally lets off a cryogenic smoke bomb. It's a world of fascinating weirdness, a perfect companion to its equally strange and beautiful primary. First, let's address Triton's most glaring act of nonconformity, its orbit. Nearly all large moons in our solar system orbit their parent planets in the same direction that the planet rotates, and generally close to the planet's equatorial plane. This prograde, orderly motion is the hallmark of moons that formed from the same swirling disk of gas and dust that created the planet itself. Triton, however, scoffs at such convention. It orbits Neptune in a retrograde direction, that is, backwards against the direction of Neptune's spin. This is a huge red flag in planetary science, the celestial equivalent of someone driving the wrong way down a one-way street. It strongly suggests that Triton is not a homegrown Neptunian moon. Instead, it's widely believed to be a captured Kuiper belt object, a wanderer from that icy debris field beyond Neptune, which we'll peek into shortly, that strayed too close and was ensnared by Neptune's gravity long ago. Imagine the cosmic drama of that capture, a chaotic, gravitational tug-of-war that would have significantly disrupted any pre-existing Neptunian moon system, flinging smaller moons into new orbits or out of the system entirely. Triton arrived and basically cleared the dance floor. And it's a substantial moon, the seventh largest in the solar system, even bigger than Pluto, its likely former cousin from the Kuiper belt. Its surface, as revealed by Voyager 2's close flyby, is one of the most bizarre and geologically active, or at least recently active, icy surfaces we've ever seen. One of the most striking features is its cantaloupe terrain, a vast area of dimpled, puckered landscape that looks, well, remarkably like the skin of a cantaloupe melon. The origin of this strange texture is still debated, possibly resulting from upwelling and sagging of icy materials, a kind of icy volcanism or diapurism. Speaking of icy volcanism, Triton is one of the few moons in the solar system known to be currently geologically active, and it does it in a very cool way, literally. Voyager 2 spotted dark plumes rising several kilometers above Triton's surface and then drifting downwind for over 100 kilometers. These are not fiery, silicate volcanoes like on Earth or Jupiter's Io. These are cryovolcanoes, ice volcanoes. They are thought to erupt nitrogen gas, laced with darker dust or organic compounds, propelled by seasonal heating from the faint sunlight. Yes, seasonal heating on a world where the surface temperature hovers around a truly delightful minus 235 degrees Celsius, minus 391 Fahrenheit. That's just a few tens of degrees above absolute zero. It doesn't take much of a temperature change to turn frozen nitrogen from a solid into a pressurized gas capable of erupting. So, Triton essentially has icy geysers, or if you prefer a slightly less dignified but perhaps more memorable term, icy farts. It's burping out plumes of nitrogen and dark dust, which then snow back down onto its surface, contributing to its surprisingly high reflectivity and contrasting dark streaks against its bright, frosty plains of frozen nitrogen, methane, and carbon dioxide. It's a world that is constantly, albeit slowly, repaving itself with chilly volcanic fallout. How wonderfully, weirdly dynamic. This ongoing activity means Triton's surface is relatively young, lacking the heavy cratering seen on many other ancient, inert moons. Something is continually resurfacing it, smoothing over the impact scars. This makes it a prime candidate for harboring a subsurface ocean of liquid water, or perhaps an ammonia-water mixture, kept liquid by heat from tidal forces, as Triton's orbit slowly decays and circularizes due to Neptune's pull, and radioactive decay in its rocky core. A subsurface ocean on a captured Kuiper belt object? The astrobiological implications are tantalizing, if still highly speculative. Could life, of some incredibly hardy antifreeze-filled variety, exist in such a cold, dark ocean, miles beneath a crust of frozen nitrogen? The universe, as usual, remains coy on this point. And Triton's destiny? It's not a happy one, I'm afraid. Because of its retrograde orbit, tidal interactions with Neptune are causing Triton to slowly spiral inwards. Millimeter by millimeter, year by year, it's getting closer to the big blue planet. In perhaps 100 million years or so, a mere blink in cosmic time, but thankfully well beyond our personal concern, Triton will cross Neptune's Roche limit, the point at which the planet's tidal forces will be stronger than Triton's own gravity holding it together. And then, well, it's going to be messy. Triton will be torn apart, shredded into a spectacular new ring system around Neptune, far grander than the faint, dusty ones it possesses today. A final, glorious, self-destructive embrace. Or perhaps parts of it will crash into Neptune, creating some truly epic atmospheric disturbances. Either way, Triton is doomed to a rather dramatic end. A tragic hero, almost. So, as we consider this strange, icy moon, this backward-dancing, nitrogen geyser-spewing captured vagabond, let's appreciate its sheer, rugged individuality. It's a testament to the chaos and serendipity of solar system formation and evolution. A world that shouldn't really be where it is, doing what it's doing, yet there it is, putting on a spectacular, if cold, show. It's a reminder that even in the most frigid, distant outposts, there can be unexpected activity, surprising complexity, and a story of cosmic drama unfolding over eons. Triton, the beautiful, doomed, flatulent rebel of the outer solar system. May its icy plumes continue to gently dust its cantaloupe skin, at least for a few more tens of millions of years. Having paid our respects to the dramatic, backward-dancing Triton, let's now turn our attention to another, more subtle and perhaps slightly underwhelming feature of the Neptunian system: its rings. Yes, Neptune, like its gas giant cousins Jupiter, Saturn, and Uranus, is a ring bearer. However, if Saturn's rings are the undisputed, ostentatious crown jewels of the solar system, a dazzling, broad, bright, multi-banded spectacle, then Neptune's rings are more like that piece of string you found in your pocket and vaguely tied around your finger, hoping no one notices it's not actual jewelry. They are faint, they are dusty, and they possess a rather peculiar, clumpy characteristic that makes them unique, if not exactly show-stopping. Neptune is, shall we say, a reluctant ring bearer. For a long time, it wasn't even clear if Neptune had a complete ring system. Observations from Earth, using a technique called stellar occultation, where astronomers watch a star pass behind a planet to see how its light dims, revealing rings or an atmosphere, suggested the presence of partial rings or arcs. It was as if Neptune had started to put on its rings, got a few bits in place, and then just gave up. Good enough, it seemed to shrug from 3 billion miles away. This was puzzling, as simple orbital mechanics suggest that such arcs shouldn't be stable. The material should spread out evenly to form a complete ring fairly quickly. Then came Voyager 2 in 1989, our intrepid outer solar system scout. Its close-up images revealed that Neptune does indeed possess a system of several complete, albeit very narrow and faint, rings. But, intriguingly, some of these rings, particularly the outermost one, named the Adam's Ring, do exhibit those dense, bright clumps or arcs that had been hinted at from Earth. These arcs, named Liberté, Égalité, Fraternité, and Courage, the French theme was strong with the Voyager imaging team apparently, are significantly brighter and denser than the rest of the ring material. It's as if most of the ring is a very sparse, dusty road, and these arcs are the occasional, slightly more crowded service stations along the way. So, what's going on here? Why are Neptune's rings so faint, so dusty, and why do they have these peculiar lumpy bits? The faintness is likely due to the composition of the ring particles. Unlike Saturn's glorious rings, which are made primarily of bright, reflective water ice, Neptune's rings are thought to be composed of much darker material, possibly organic compounds processed by radiation, or fine dust, making them absorb more light and reflect less. They are essentially dirty snowballs, or perhaps just cosmic grit and grime, which doesn't make for a very dazzling display. The solar system's equivalent of that dusty old lampshade in the attic. The dustiness itself is also a clue. Small dust particles are susceptible to various forces, like solar radiation pressure and Poynting-Robertson drag, a fancy term for sunlight causing tiny particles to spiral inwards, which should cause them to dissipate or fall into the planet relatively quickly, on cosmic timescales. The fact that Neptune has these dusty rings suggests they are either relatively young, or they are being continually replenished from some source. Perhaps small, unseen moonlets embedded within or near the rings are constantly being eroded by micrometeoroid impacts, kicking up fresh dust to keep the rings supplied. Or maybe the occasional captured comet or asteroid gets torn apart, its debris feeding the system. And those persistent arcs in the atom's ring? That's the real head-scratcher. How do they stay confined? Why don't they spread out? The leading theory involves gravitational interactions with a small, nearby shepherd moon called Galatea. Galatea orbits just inside the atom's ring, and its gravity is thought to create specific points of stability, known as Lindblad resonances, that can trap ring particles, corralling them into these denser arcs. It's like Galatea is a tiny cosmic sheepdog, carefully herding its dusty flock into these specific, clumpy formations. It's a delicate gravitational dance, a subtle interplay of forces that allows these otherwise improbable structures to persist, at least for a while. It's all very understated. Neptune is clearly not trying to compete with Saturn in the most fabulous rings competition. It's more of a minimalist when it comes to its orbital accessories. Yes, I have rings. They're there. Don't make a fuss. It's almost endearingly modest for such a giant, stormy planet. There are several distinct rings identified. The faint, broad Gal ring closest to the planet, then the narrower Leverrier ring, the even fainter and broader Lassell ring, which may be more of a sheet, the Arago ring, and finally the Adams ring with its famous arcs. Most of these names come from astronomers and mathematicians involved in the prediction and discovery of Neptune itself. So there's a nice historical nod in their nomenclature. Imagine trying to spot these from Earth. It's an incredible feat of observational astronomy. They are so faint and so close to the glare of Neptune itself that detecting them requires immense skill, patience, and very sophisticated equipment. It's like trying to spot a cobweb across a football field at night with a searchlight shining in your eyes. So, while Neptune's rings may not inspire the same immediate jaw-dropping awe as Saturn's, they present their own quiet set of mysteries. They tell a story of dark, dusty material, of ongoing replenishment processes, and of delicate gravitational shepherding that creates surprisingly stable, if clumpy, structures. They are a subtle accent to Neptune's deep blue grandeur, a whisper of complexity rather than a shout. A reminder that not all cosmic beauty needs to be dazzlingly bright. Sometimes, the most interesting stories are found in the faint, dusty, and slightly lopsided details. Neptune, the reluctant ring-bearer, wears its subtle adornments with a quiet, icy dignity. And perhaps, in their understated way, they are all the more intriguing for their shyness. Our exploration of Neptune and its immediate family, its moody spots, its icy cirrus, its rebellious moon Triton, and its shy, dusty rings, has shown us a world of remote, cold beauty and surprising dynamism. But Neptune isn't just a solitary outpost. It's also a sentinel, a guardian standing at the precipice of an even vaster, darker, and more mysterious realm. As we begin to pull away from Neptune in our imaginary vessel, let's cast our gaze outwards, beyond its orbit, into the chilling expanse known as the Kuiper belt. This is where the solar system truly begins to fray at the edges, where organized planetary structure gives way to a scattered wasteland of icy remnants from the dawn of creation. Peering past Neptune, we are looking into the deep freeze of the outer dark, where cosmic loneliness gets a significant upgrade. The Kuiper belt is a vast, donut-shaped region of space extending from roughly Neptune's orbit, around 30 astronomical units, or AU, from the Sun, and AU being the Earth-Sun distance, out to about $50 Australian, though some estimates push its outer edge even further. It's like a colossal debris field, a cosmic junkyard littered with countless icy bodies, ranging in size from small chunks of frozen gas and rock to dwarf planets like Pluto, Eris, Makemake, and Haumea. These are the leftovers, the unused building blocks from the formation of the solar system some 4.6 billion years ago. While the inner solar system saw these planetesimals accrete into rocky planets, and the gas giant region formed its colossal worlds. Out here in the frigid far reaches, things never quite got that organized. The material was too sparse, the orbital times too long for large planets to coalesce. So these icy bodies remained, frozen in time, primordial relics orbiting silently in the dim twilight. Imagine trying to count them. Estimates suggest there are hundreds of thousands of Kuiper belt objects, KBOs, larger than 100 kilometers across, and perhaps trillions of smaller, comet-sized bodies. It's a population density that sounds crowded, but spread across such an immense volume of space, the Kuiper belt is mostly empty. Vastly, overwhelmingly empty. If you were floating in the middle of it, you likely wouldn't see another KBO with your naked eye. The distances between these objects are still enormous. It's not the asteroid belt of popular science fiction, a chaotic jumble you have to deftly navigate. It's more like a few scattered, very cold potatoes in an unimaginably large, dark cellar. And cold it is. Out here, the sun is a distant, brilliant star, but its warmth is negligible. Surface temperatures on KBOs typically hover around -220 to -240 degrees Celsius, around -370 to -400 Fahrenheit. These are worlds locked in a perpetual deep freeze, their surfaces coated in exotic ices like frozen nitrogen, methane, carbon monoxide, and water ice harder than granite. Any atmospheres they might possess would be incredibly tenuous, perhaps seasonal whispers of gas sublimating from their icy surfaces when they make their closest approach to the distant sun on their long, elliptical orbits. Neptune plays a crucial role in shaping the Kuiper belt. Its immense gravity sculpts the inner edge of the belt and influences the orbits of many KBOs through gravitational resonances. For example, Pluto and many other KBOs, known as Plutinos, are in a 2:3 orbital resonance with Neptune, meaning Pluto completes 2 orbits around the Sun for every 3 orbits Neptune makes. This resonance, paradoxically, keeps them safe from colliding with Neptune, even though their orbits cross its path. It's a delicate gravitational dance that Neptune leads, its influence extending far out into this icy frontier. Neptune is the shepherd, and the KBOs are its very, very widely scattered frozen flock. This is the region from which many short-period comets originate. Occasionally, gravitational nudges from other KBOs, or perhaps the cumulative pull of Neptune over eons, can send one of these icy bodies careening inwards towards the Sun. As it warms, its ices begin to sublimate, creating the characteristic cometary coma and tail that can sometimes grace our night skies. So, when you see a comet, you're often looking at a visitor from this distant, frozen reservoir, a messenger from the outer dark. A rather dirty, icy snowball that has decided to take a road trip to the inner solar system. The study of KBOs is incredibly important for understanding the early solar system, because they have remained largely unchanged, locked in their frozen state for billions of years. They are like time capsules. Their composition, their distribution, their orbital characteristics, all provide vital clues about the conditions and processes that govern the birth of our planetary system. They are the primordial rubble, and by sifting through it, metaphorically with telescopes and spacecraft like New Horizons, which gave us our stunning first close-up views of Pluto and Arrokoth, we can piece together the story of our origins. But imagine the sense of isolation out here. If you thought Neptune felt remote, the Kuiper belt takes it to a whole new level. This is true deep space within our solar system. The light is faint. The silence is absolute. The distances are mind-numbing. It's a realm of profound, cold, and enduring loneliness. Any life that could exist here would have to be incredibly strange, incredibly resilient, and probably very, very patient, waiting for the occasional photon of distant sunlight. It's a stark contrast to the bustling inner solar system, or even the dynamic, stormy environment of Neptune itself. The Kuiper belt is a place of slow processes, of immense timescales, of quiet, frozen grandeur. It's where the sun's influence truly begins to yield to the vast emptiness of interstellar space that lies beyond. It's the solar system's attic, full of forgotten relics and ancient dust, whispering tales of a time long past. So, as Neptune recedes behind us and we gaze into this sparsely populated, icy wilderness, let that sense of vastness, of cold, of ancient stillness settle over you. It's a place that makes even our most profound earthly anxieties seem rather fleeting. The Kuiper belt doesn't care about your deadlines, your worries, your regrets. It simply is a silent, frozen testament to the universe's beginnings. And in that profound indifference, there's a strange, deep peace to be found. The cosmic loneliness of the Kuiper belt is a cold, but ultimately calming, embrace. We've journeyed far tonight, haven't we? From the initial chilly welcome mat of Neptune, across its methane blue face, through its supersonic winds and past its ghostly storms. We visited its rebellious moon Triton and acknowledged its shy, dusty rings. We've even peered beyond into the frozen, lonely expanse of the Kuiper belt. It's been quite the grand tour of the solar system's outer suburbs. And now, as our cosmic sightseeing expedition begins to wind down, perhaps it's time for a little re-entry. Not into Earth's atmosphere, not yet. But a re-entry into an appreciation for something much closer to home, something wonderfully mundane, yet in light of our recent travels, something incredibly precious. Your couch. Or your bed. Or whatever comfortable, terrestrial surface is currently cradling your weary form. Because, let's be brutally honest for a moment, why your couch, or indeed any vaguely habitable spot on Earth, is infinitely cozier than attempting to exist on or even near Neptune. This is where we appreciate the sheer, unadulterated terror of trying to be on Neptune, making your everyday life feel like a 5-star spa day by comparison. Let's recap the Neptunian experience, shall we? First, the temperature. Cloud tops at a brisk -218 Celsius, or -360 Fahrenheit. That's not just chilly. That's your atoms stop vibrating and politely ask to be excused from existence cold. Your warmest winter coat, your most technologically advanced thermal underwear? They would offer about as much protection as a single layer of wet tissue paper in a blast furnace, only in reverse. You wouldn't shiver, you'd shatter. Your bodily fluids would freeze solid before you could even form the thought, perhaps I should have packed a scarf. Cozy factor on Neptune. Approximately 0 Kelvin, which is coincidentally colder than Neptune, but you get the idea. Your couch, with its soft cushions and perhaps a nearby throw blanket? Infinitely superior. Then the atmosphere. Or lack thereof in terms of anything a human could breathe. It's mostly hydrogen and helium with a dash of that delightful methane which, while providing the pretty blue color and lovely ice clouds, is an asphyxiant. Oxygen? Nope. Not a trace. So, even if you could somehow survive the cold, your first breath would be your last, and it wouldn't be a refreshing one. It would be a, my lungs are now full of unbreathable frigid gas kind of breath. Your couch, situated in a room presumably filled with a lovely, oxygen-rich nitrogen-oxygen blend we call air? Looking pretty good right about now, isn't it? Next up, the winds. Ah, those gentle Neptunian breezes. Clocking in at over 1,200 miles per hour, or nearly 2,000 kilometers per hour. Supersonic. Winds that would not just ruffle your hair but remove your hair, your skin, your flesh, and distribute your constituent molecules evenly across several latitudinal bands. Trying to stand on a non-existent, solid surface in that kind of wind would be like trying to have a picnic in the direct exhaust of a Saturn V rocket during launch. Your couch, hopefully, is not currently experiencing supersonic winds. If it is, you have far bigger problems than falling asleep. And the pressure? While the upper atmosphere we've been notionally floating through has very low pressure, if you were to descend deeper into Neptune hoping to find, say, those diamond rain layers, the pressure rapidly becomes expressive. Millions of Earth atmospheres. We discussed the human pancake, or human smear scenario. It's not an attractive look. Your couch, bless its springs and stuffing, exerts a gentle, supportive pressure, just enough to feel comforting, not enough to compress you into a new state of matter. Radiation? While Neptune itself isn't a particularly nasty radiation source like Jupiter with its lethal radiation belts, you're still out in the depths of space. Cosmic rays, solar wind particles, however diminished at this distance. Without Earth's lovely magnetic field and thick atmosphere to protect you, your long-term and even short-term health prospects would be grim. Your living room, hopefully shielded by walls and a roof, offers a significantly more benign radiological environment. You're more likely to get irradiated by a twilight marathon than by ambient cosmic radiation in your home. And what about a place to stand? Neptune is an ice giant. It doesn't have a solid surface in the way Earth does. It's a huge ball of gas and fluid that gets denser and hotter as you go deeper, eventually transitioning to a slushy, icy mantle and perhaps a small, rocky core. There's nowhere to build a summer cottage, nowhere to plant a flag. If you landed on Neptune, you'd just sink, and get crushed. And cooked, and then possibly turned into a tiny diamond, which sounds glamorous but is probably less fun than it sounds when it's you. Your couch, on the other hand, offers a delightfully stable, non-sinking platform for repose. The sheer, overwhelming scale and indifference of it all. Out there you are a speck. A fragile, warm, soft speck in a universe that is largely cold, hard, and utterly unconcerned with your well-being. Neptune's storms don't rage for you. Its winds don't howl your name. Its beauty is accidental, a byproduct of physics, not an invitation. Your couch, however, was probably designed with your comfort in mind. Or at least, with the comfort of a generic human form, which is close enough. It's for you, in a way that an ice giant 3 billion miles away most emphatically is not. So, as you lie there, feeling the gentle gravity of Earth holding you, the soft support beneath you, the comfortably warm, breathable air around you, take a moment to truly appreciate these simple, life-sustaining luxuries. Our journey to Neptune, with all its stark realities and cosmic buzzkills, is not meant to terrify you out of sleep, but to lull you into it through a profound, almost absurd sense of gratitude for the mundane. Your home, your bed, your couch. These are your personal, life-friendly spacecraft in a universe that is mostly trying to kill you in a spectacular variety of ways. And that, my friends, is a wonderfully relaxing thought. The sheer, unadulterated terror of Neptune makes your current situation seem like paradise. Sweet, cozy, non-supersonic wind-having paradise. And so, our long imaginary voyage to the realm of the ice giant Neptune, and its even more distant frozen frontiers, draws to a gentle close. We've drifted through its deep blue atmosphere, a color born from the mundane magic of methane filtering sunlight. We've braced ourselves, mentally at least, against winds that scream silently at supersonic speeds, a testament to an internal heat source that still whispers its secrets from the planet's core. We've chased the ghostly, ephemeral great dark spots, storms larger than our Earth, yet fleeting as a planetary mood. We've marveled at the delicate, deadly beauty of methane ice cirrus clouds, pretty daggers in a sapphire sky. We recalled Voyager 2's fleeting, historic encounter, a brief hello and a long goodbye that left us with more wonder than answers. We pondered the faint, unsettling warmth of Neptune's inner furnace, and the glittering, crushing prospect of diamond rain in its abyssal depths. We've danced in our minds with Triton, Neptune's rebellious, backward-orbiting moon, with its icy geysers and cantaloupe skin, a captured vagabond doomed to a spectacular demise. We've acknowledged Neptune's reluctant, dusty rings, clumpy and understated, a subtle adornment to a majestic world. And we've peered beyond into the profound, frozen loneliness of the Kuiper belt, the solar system's attic of primordial debris. What a journey it has been. From the edge of our solar system, we've looked back at the familiar, and perhaps seen it with new eyes. The sheer, unadulterated hostility of Neptune's environment, the annihilating cold, the unbreathable air, the flaying winds, the crushing pressures, serves as a stark, almost comical counterpoint to the gentle comforts we often take for granted here on our little terrestrial oasis. It's a universe that is, by and large, not built for us. We are the exceptions, the fragile, fleeting anomalies in a cosmos that operates on scales of temperature, pressure, and violence that dwarf our comprehension and would extinguish our existence in an instant. And yet, in contemplating this vast indifference, this majestic, terrifying grandeur, there is a strange and profound peace to be found. Neptune, with its swirling storms and deep blue beauty, doesn't know you exist. It doesn't care about your worries, your triumphs, your anxieties about tomorrow's to-do list. Its winds were raging long before humanity even dreamed of looking at the stars, and they will continue to rage long after our fleeting moment on this planet has passed. This isn't a depressing thought, not tonight. Tonight it's a liberating one. Your personal dramas, your daily struggles, are infinitesimally small against this cosmic backdrop. They are a single, faint mote of dust in a storm system the size of a world, on a planet 3 billion miles away. And in that insignificance there is a kind of freedom. A freedom to let go. The deep blue of Neptune, born of simple atmospheric chemistry, can become a color of calm in your mind. The silent, supersonic winds can become a metaphor for the chaotic energies of the universe, energies that are far beyond your control, and therefore perhaps not worth wrestling with as you seek the solace of sleep. The fleeting nature of the great dark spots can remind you that even the most imposing challenges eventually fade, that change is a constant, even on a planetary scale. The universe is full of these surprising truths, beauty forged in lethality, complexity arising from simple laws, indifference coexisting with intricate order. Neptune is a perfect embodiment of this. It is a jewel of the solar system, a breathtakingly beautiful world, and simultaneously, a place where you would die 1,000 different, very unpleasant deaths in the span of a heartbeat. And it's okay to hold both of these truths in your mind at the same time. It's okay to marvel at the beauty while wryly acknowledging the terror. That's the exquisite, often darkly humorous paradox of existence. So, as you allow your consciousness to drift, untethered, into the welcoming darkness of sleep, let the image of Neptune remain. Not as a threat, but as a distant, majestic anchor for your thoughts. A reminder of the vastness out there and the preciousness of the small, warm, safe space you inhabit right now. The universe will continue its grand, indifferent waltz. Its storms will rage, its worlds will spin, its diamonds will reign in crushing darkness. And you, tiny, precious human, can simply rest. You've seen the edge of the solar system tonight. You've faced its cold, harsh truths with a brave, sleepy curiosity. And now it's time to come home to the quiet harbor of your dreams. Neptune will still be there in the morning, a distant blue point of light, utterly unconcerned, and that, in itself, is a deep cosmic comfort. And so, dear cosmic Voyager, our journey to the far reaches, to the deep blue majesty of Neptune and the chilling expanse beyond, gently concludes. The images of swirling sapphire storms, of winds faster than sound, of diamond rain in crushing darkness, and moons that dance backward to their doom, now begin to soften, to recede like the tide pulling away from a silent shore. Let them fade into the gentle velvet of your mind, leaving behind not anxiety, but a profound sense of cosmic perspective, a wry smile at the universe's beautiful, terrifying absurdity. The universe, in its infinite, cold, and occasionally hostile splendor, will continue its grand, indifferent ballet. Neptune will keep spinning its icy heart out 3 billion miles away, completely oblivious to your existence, which is, frankly, a rather comforting thought. It has its own problems like those pesky supersonic winds and the mystery of its internal heat. Your earthly concerns, in comparison, might now feel just a little bit smaller, a little less pressing, like distant stars rather than burning suns in your immediate sky. As you lie here, nestled in your own small, safe haven, remember that even amidst the vast, uncaring cosmos, there is beauty, there is wonder, and there is the profound peace of acceptance. The universe may not care if you sleep well, but we do. And knowing that it's mostly trying to freeze, crush, or irradiate you, while simultaneously displaying such breathtaking artistry, somehow makes your warm bed feel like the most luxurious spaceship in the galaxy. So, let your breath be slow and even like the long, lazy orbit of a distant comet. Let your muscles soften and release, like stardust settling on a silent moon. The vastness of space, the crushing realities, the existential shivers, they are all out there. But in here, in this quiet moment, there is only peace, only stillness, only the gentle invitation to drift. Sweet dreams, Voyager. You've earned them. The cosmos, with all its beautiful terrors and stunning indifference, can wait until morning.